welcome to the 11th episode of the Weaviate Podcast. Today I'm joined by Rick Lammers, the CEO and founder of Orchest.io. Orchest is such an amazing software. It's one of those things when I first saw it in my day-to-day workflow, I just said, wow, this is something that I need to be using. And I'm so excited to be talking more about this and learning more about the future of this and how the idea came about and all sorts of things related to this super cool software. So with that said, to kick things off, Rick, can you tell us about what is Orchest?
Hey, Connor. Thanks for having me. Of course, happy to share more. Orchest is really a tool targeted at data scientists to simplify building batch data pipelines. And so what we believe to be true is that data scientists have this incredibly productive existing workflow, and typically it involves rapid iteration, use of Jupyter notebooks, and they're comfortable and productive in that environment. And we wanted to take that workflow and bring it closer to the process of productionizing these types of scripts and notebooks to a batch runnable data pipeline with all kind of attributes one might expect a data pipeline deployment tool to have. But we really had the vision to make it accessible and familiar to data scientists, data analysts who are comfortable writing Python and R, and even Julia or Bash for that matter. We're pretty language agnostic. And that's what we've tried to build. So if the audience is familiar with something like Apache Airflow, they can see Orchest as a similar version to that, but a much simpler story around how to actually deploy it, and really a lot more accessible in terms of more similar to the vibe you get when you open something like a Jupyter Lab.
Yeah, I think even if you have no experience with production and deployment, if you go to Orchest and you watch their introduction video, you will instantly, it takes maybe 30 seconds to understand how to plug in together the pipelines. And I love the way that it decomposes your Jupyter notebook. So, if you're a data scientist working with these Jupyter notebooks and you collect these monolithic notebooks and maybe you're organizing them with like the hashtags to collapse the tabs and have that kind of organization compared to these pipelines where you can just separate out the things. So what kind of things went into the design of this UI? How do you see the future of IDEs with data science notebooks? And I love the fusion between Python scripts and Jupyter notebooks that are in the Orchest layer. So how did you come up with this kind of user interface design, and what are your thoughts around it generally?
So great question, and we really spent a lot of time thinking about the design of the tool, and it was kind of building something we'd want to be using ourselves. We'd been both working as data scientists in the field in larger teams, and what we felt what was needed was the flexibility to use the right tool for the job. And so what we felt like was sometimes the right tool for the job was a notebook, because we could really appreciate the kind of REPL oriented style of coding in a notebook. And for particular types of tasks, that kind of very rapid iteration can be very helpful, especially if you're doing kind of exploratory data analysis. But we also sometimes felt that once we had a very clear vision of some sort of isolated modular piece of code that is just really kind of an abstraction or clear abstraction of certain functionality, maybe in Python classes, that it feels very awkward to write that inside of a notebook. So we wanted a tool that could blend the simplicity of scripting and notebooks and allow us to kind of flexibly piece them together in a way that requires very little changes to the way we worked. Because I remember looking at all kinds of either MLOps or workflow orchestration tools, and they just asked so much in terms of like, please change your entire worldview and really buy into our framework, transform your entire code base into this, application that's coded against our API. And there's just so much buy-in at the code level into the scheduler framework that really didn't make sense to us. We were like, I just want a way to bundle and connect and schedule this code, but I don't want to make the code like dependent on a third-party framework and really embed that into the code. And I think Apache Airflow, for all the wonderful things it brings, and it's really an innovative project that has brought many good things. I think once you realize that like the entire scheduling and data science processing code is kind of fully intermingled, you can start to realize some of the downsides, especially if you want to think about the deployments in a bit more flexible way, where sometimes you're deploying on your local machine because you're testing, but sometimes you want to deploy on a larger cloud cluster. And like, how do you not become intermingled with your scheduling framework too much?
Yeah, the modularity of it is incredible, and I love that the minimal buy-in when you're adding this new ML ops tool. I completely understand what you're saying, where you have all this integration that you have to do to tie your code base into most of these existing ML ops tools. So another thing I wanted to talk about, and something that again just stood out to me, is wow, I need to have this. This is so incredible. Is the cloud abstraction that you've provided with Orchest, and things like say you have a web scraping Python script that scrapes your data from some
Mm-hmm.
website, and you want to schedule that as a cron job where you have it run every day or every week, or say you want to schedule the retraining of your models every week, once a week. And Orchest has this beautiful integration where to access these cron job services is just like a few clicks to be scheduling it up. Can you tell me about overall this idea of like these cloud abstractions where you simultaneously build a software platform for MLOps, but you also kind of abstract away the complexity of the cloud computing into the software as well?
Yeah, I think you mentioned a great example, scraping. A friend of mine was trying to buy a house, and he really wanted to make sure that he got like quick information notices the moment something came available. And so he was writing these cloud scraping or these Python based scraping algorithms and this bit of code. And the advantage that Orchest then provides is that if you're thinking about deploying this as kind of a regular cron scheduled job to execute, you also often need to think about the dependencies you need to have installed. And in particular, I think because he was familiar with Selenium, he wanted to use Selenium in the project. And what Orchest bundles as part of its platform, because it's fully based on containerization behind the scenes, so not very explicitly exposed to the user. You don't have to know anything about Docker or Kubernetes, but behind the scenes, everything's a container. It allowed him to just specify the system level dependencies, even, and the Python dependencies of the Selenium Python package. And he could just bundle this whole thing and deploy it very easily as a pipeline. And all he needed to do is in the Orchest web UI, he just needed to run the bash commands he would normally use on his local computer, right? So it's like whatever you would normally type into your terminal to make the dependencies work, basically one to one, you can input that into the Orchest, what we call environment setup script, and it's like just a bash file that gets executed, and it's almost like fine tuning an ML model, but it's like fine tuning a Docker image. So it's like the final steps to fine tune your Docker image to the dependencies that you need. And therefore, it becomes very easy to take your full pipeline and just run your quick setup script and then actually run your code. And we can then deploy that anywhere. So for him to be able to have system level dependencies like Selenium really made it easy to like deploy that as a bundle directly in the Orchest environment without ever having to leave the browser, right? And I think that's really powerful, that you can be at the abstraction layer of containers without actually having to worry or know about them. So you get the power, none of the complexity. And that's really kind of in line with the main goal of the product.
It's extremely exciting for the adoption of the technology, and yeah, like you say, like you don't even have to leave the browser to set up the different Docker containers and integrate different scripts that use different kinds of dependencies, and all flowing into this pipeline. So kind of later on in the podcast, we're going to talk about the integration with Weaviate and how you connect these pipelines into Weaviate's, say, Python script to process the web scrape documents and then put them into your Weaviate database. But first, I want to talk a little bit more around these topics around ML ops. And I think, so personally, I'm just coming out of a project where I've developed this thing called KerosBERT. It's a language model of Keros information, and I've been adding data sources with these pipelines that I just think would just fit so perfectly with Orchest. When I saw the initial diagram, I just thought, wow, this is exactly what I'm doing in a much more organized way. I love the look of this. And so thinking about continual learning and that kind of research project as you're integrating and reusing your models, and particularly these as you add data sources and then you add new generalization tests. Is continual learning maybe the aspect of ML ops? And then following from here, I want to talk about hyperparameter tuning, but is continual learning kind of maybe the key focus of this?
I think continual learning is getting more attention, and rightly so. I think the notion that you train your model once and that you're basically done is kind of a notion that's no longer held by most of the ML community. They all kind of realize maybe you start out with something, but sooner rather than later, you're going to detect and identify the areas in which your model is not generalizing well, and you're going to want to feed it examples that will basically fill out those holes, if you will, of the generalization landscape. And the way Orchest thinks about this is that a lot of the retraining can easily be formulated as a scheduled job or a job that gets triggered under a certain condition. And so what we generally recommend people to do is to build a pipeline in Orchest and to make it idempotent. So if you run it multiple times, you will basically get quote unquote the same result. But if instead of making it truly idempotent, but really kind of make it refetch the latest kind of training source, wherever you have that stored, you basically can kick off a pipeline many times whenever you feel like it's a good moment to retrain. And of course, you also want to get some insight into how that retraining went, right? And that's where the beauty of having notebooks as part of your production pipeline comes in, because a notebook has the element of capturing the rich data that is generated on disk in the file itself. It's the Jupyter notebook format. It contains this output, and it has a huge advantage, which means that if you run this pipeline and retrain your model, you can also capture with it not just the trained artifact, but also all these kind of data points that you might care about, like what does the generalization look like, or you maybe even have an updated test set because you maybe have expanded your test samples in order to now account for these areas you discovered were underperforming. So I think the model of batch processing goes hand in hand with continual learning of models. Even if your model is really just a fine tuning of a larger trained model in NLP, this is often the case. I think this kind of batch model just really aligns with that reality of needing to continuously improve the quality of your predictions.
Yeah, and coming back to this idea of how it's bare bones, there's so little buy-in for using the Orchest framework. If you want to integrate, Hugging Face transformers, the Gina AI fine tuner, or maybe say Mosaic ML's composer, rubrics data labeling, or all these things like even weights and biases, hyperparameter tuning, or say determined AI hyperparameter tuning, you can integrate all these things into the Python scripts, and they just easily plug into Orchest, which is another thing I just think is so exciting about this. So can we talk a little more also about hyperparameter tuning? I know some of that is built into Orchest as well. What are your thoughts around that kind of idea?
Yeah, I think anyone who's tried to train a model will discover that it's not so much of an exact science as much of a black art, where you're really trying to identify how, in what configuration is my model behaving optimally, and it's not always clear a priori how that, like what that looks like in terms of hyperparameter configuration. One of the design goals for Orchest has always been to take the best in class open source tools at the disposal to the data scientist or the machine learning researcher or engineer, and make them easily integratable in that environment. So because we're at the abstraction layer of containers, you can take advantage of the whole range of open source tools and the ecosystem available to do your model training. And a really cool example that I think the especially the NLP crowd will recognize is the Koki text to speech, speech to text tools that are available. Like, its command line can just be integrated simply into Orchest, and that can even trigger like training jobs that are not even in a specific language, but they're actually just like command line invocation of a tool that's available. And I think this kind of agnosticity really allows you to take advantage of all the work that's going on in the ecosystem and not really tie yourself into a specific language or framework. And that's been the goal since day one, is how do we empower that existing workflow, but also how do we make sure we leverage all of the ecosystem and not just the strict subset of Python. Because frankly, if you look at a lot of like sophisticated statistics, a lot of really good work is going on in R. And I think, giving those people second-rate experience would, I think, be really bad if you're building an orchestration tool, right? I think that should be at a much more generic level than biasing a particular language.
Yeah, and I think the integration of, say, in Weaviate, as we build deep learning for search and we build search pipelines, you could think of this orchestration layer. It's just so amazing the way that you can connect all these pipelines. So usually in these search pipelines, we have retrieval, then we have some kind of retrieval fusion, then we have, say, re-ranker, question answering, summarization, supervised learning models at the end of it. So in this orchestration pipeline, you could add the inference features as well, the routing in the pipeline, connecting the scripts to each other. So it's such a great abstraction for, say, you want to have your particular component where you're updating your embedding model, or you have some other pipeline for how you update your re-ranker model. And this whole thing of creating this whole end-to-end experience where it can be not just training, but also inference. Have you thought a lot about also the pipelines for maybe, say, like ensemble learning and aggregating inferences?
I think ensembles are a great example of how real ML has converged to realizing that it's a powerful technique, even though like the theoretical analysis of an ensemble model is super difficult because you're dealing with sometimes very foundationally different concepts of how prediction is generated. So integrating that mathematically is super hard, but in practice, it tends to really work super well, right? So you might want to make use of it. So if you're doing kind of multi-model inference in order to get an ensemble result, how do you make sure that the code ends up being sane? Like, how do you make sure that this thing still feels like something you can control? I really remember the stories of Kaggle, where competition winners would often have solutions that are so complicated that the winners would not even be able to implement it for the company who was organizing the competition because it was just so complicated. So what we're really trying to do in Orchest is to get that modularity where a single step can represent the inference of a single model, and you can even have these steps be parameterizable. So you could even have a single piece of code or a single script or notebook that takes in a parameter which basically chooses the model, and then you can use that same step multiple times in a single pipeline. And then there's some sanity and overview, right? You know exactly that this step is generating the result, and you can have it very visually laid out. And I feel like that approach of providing structure, so you at least can see at a glance of what is my pipeline doing in totality, is very powerful if you're not working by yourself in particular. I mean, it's good to have overview for yourself, but typically you have a pretty good representation of what you're building in your mind. I'm sure all coders can relate that they can like blindly navigate the ideas they have, but that's not so much true if you're working together, right? Because you can't really look inside each other's mental models, and so we have to indirectly communicate intent. And I think the DAG just really naturally lends itself for this, right? So that's why we really like the experience that we've been getting described back to us from users of Orchest. They'll tell you, look, I remember inheriting a pipeline that was written in one of these abstract frameworks that allows like almost arbitrary degrees of freedom in terms of how the DAG is actually generated. So it can take on arbitrary complex shapes, and then getting like an Orchest pipeline where it's just like pretty declaratively defined. It's just like this one defined DAG, and I can much more easily find my way through like, okay, what's happening start to end. And I think you asked about ensembles. I think it's one of those examples where if you've ever touched a code base where ensembles are used, you'll get that feeling of being a bit lost of like what's happening where.
Yeah, I think it's so interesting too for interacting components of systems. Like, say, you have again these search pipelines where you have several different components of it, and yeah, I love the Kaggle competition pipelines. That example, like knowing about Orchest now, it makes it so easy for me to visualize these things. The DAGs, as you say, just thinking about plugging it into DAGs, having the modularity, and then also the cloud integration coming back to that. But it just makes it so easy to visualize how you would really engineer things like this. And that's just something that is inspiring so much excitement with me about learning about Orchest. And also say things like reinforcement learning workflows, where you might have some model-based agent, you might have your Q-learning, you're separating all these components out. Maybe you have like a generative adversarial network that generates data that comes back into your supervised learning model. All these components that flow through each other. And this is just coming back to, I think, because there's such a little buy-in, it's your Python code, it's so easy to understand how this thing connects together. So kind of to come into a like these real examples you have with Orchest, can you tell me more about your integration with the forum scraping and Weaviate and creating the question answering system?
Yeah, of course. So the really nice thing, like you mentioned with Orchest, is that you can take an existing code base, and you might have your work divvied up among like 5 notebooks. You maybe have numbered them neatly, and it's like 1, 2, 3, 4, 5. Or you could have a couple of scripts that you usually execute using the command line, and you parameterize them. Like the way to get started in Orchest is just like you drag that file onto the canvas, and it's a step, and it will get executed in its own container. And you have to do almost no work to go from existing code base in a GitHub repository. You just import the repo as a project directly, and you can get started. And so one of the challenges that I wanted to use as a way to evaluate, are we doing a good job with Orchest, is can I take like a very simple example of how to use Weaviate from Python for data ingest, and then also for searching with GraphQL. Can I make an Orchest pipeline out of that does this in the most straightforward way? And that experience honestly was really like, in a way, it was a relief, because it was like testing our internal hypotheses about like how the product should function, and it turned out to work. So that was a nice experience. And the end result is basically a code base that, if you look at it outside of the context of Orchest, you could just run it, and you could basically just see all of what's happening for like the ingest and querying the Weaviate engine from a Streamlit context. So the way this pipeline works is we allow you, like I mentioned, to integrate third-party services. So we have a Streamlit application, a Weaviate database running, and then the Orchest pipeline itself is in charge of fetching data from the internet, scraping basically comments, and then injecting them into the database. And so the actual pieces of code are just like fully independent of Orchest. Like Streamlit is just a Streamlit app. It's a Python file. It loads itself. It speaks for itself. It's very simple. And then the Weaviate service running is just like a very simple instantiation of the container service that Weaviate provides. So all of these pieces individually, nothing of that really requires any kind of Orchest knowledge. But then the final layer that makes it all work is that you have this one pipeline file, which is the Orchest file, and that pieces together all these things. So it pieces together the container services. So it has the definition for the Streamlit container, it has the definition of the Weaviate container, and it has the code inside of it to drive the Streamlit app, to drive the ingest into Weaviate. And so these pieces are basically glued together by Orchest. And the way you do that is by simply just like connecting a couple of things in the graphical interface. And I think like the fact that that full definition is then fully versioned as part of the repository, and allows someone to take this pretty complicated thing, which is like web scraping that like actually scales, ingests into a vector database, then serves an application on its own port that runs the Streamlit code to generate the dashboard that lets you interface with the Weaviate database from a querying perspective. Like, to have that as actually like one simple project in a normal GitHub repository that you can import as a template and just start editing and playing with, I think that really shows the power of 3 really cool tools combined, right? Like, it's the simplicity of Streamlit, it's the power of Weaviate for both ingest and querying, and then kind of like piecing it together as an orchestrator that didn't require to change any of those other 2 parts, right? Which was the main idea. So yeah, that to me was just hugely exciting to be able to like see that thesis of integrating other best-in-class open source into a single tool come together. That was just really fun, honestly, to build as a project.
Yeah, and we haven't even talked about like Streamlit and Gradio and how that brings the user interface also as a part of these pipelines. And again, just easy Python code that can be wrapped into these pipelines. It's just so exciting. And then So we've talked so much about the engineering details. I want to kind of step up a little bit and talk about this application of searching through blogs and question answering through blogs. Do you see that kind of changing the fundamental way that we use, say, kind of like blogging and social media and that kind of general thing?
Absolutely. I think we have this unique opportunity today. I mean, everybody has been talking about big data and like so much data becoming available and like so much data being generated at every given minute. But it's really true. And if you think about the implication of having this much data, it can actually improve fundamentally how you operate. And I think now that tools are coming available to make this easier to do, even with a simple example like I made, like what I built at a high level, like without the technical details, is it allows you to search through comments of someone on a forum. And it's this famous Dutch forum. It's called Tweakers. It's for people who love technology. And I remember when I was thinking about going to grad school, I was doing a lot of searching on the forum because I really wanted to understand people's experiences having gone through that. And I realized that the data was publicly available because the forum was publicly accessible, but the search was really, honestly, it was quite bad. So I really didn't have a good way to get to that data and query it. And so I think with the amount of data available and now powerful paradigms like vector search engines coming available to be able to actively activate that kind of knowledge, which is like a huge sea of data, but how do you actually tap into it? I think that's the key. And applications are now coming available that make this simple. And I think Codex, is a great example of taking all this embedded knowledge of like how to write against a new API of something. Like writing your first Flask app with and without Codex is just night and day, right? And so that's tapping into source code. I'm tapping with that example into all kinds of tacit knowledge that people have about like school and education, specifically in the Netherlands. And so I feel like actually being able to tap into that data is such an exciting trend. And I love seeing all these kind of like intuitive or like ingenuitive projects from people who find public data resources and really do something interesting and cool with it. And so like concepts like open data, but even just like accessibility of like Reddit data, forum data, like I think that's really, really exciting.
Yeah, your example with vector search has really opened up my thinking about what might be the future of, say, YouTubing and making content for technical knowledge. And I was thinking a lot about my YouTube channel with deep learning videos and how we kind of, with question answering, we kind of have like two paradigms where there's extractive question answering and abstractive question answering. And abstractive question answering kind of encapsulates this idea where like you turn me or say Yannick Kilcher, someone who makes content, into like a chat bot, and now you can like talk to that chat bot and they can generate novel responses, compared to extractive question answering where you really just need to match your question with a clip in the YouTube video. And thinking about your example with vector search with this blog website, I was thinking a lot about how you can transcribe all of the YouTube videos to create this big text document, and then with the question answering you can match it to a text snippet and then get the 30-second video. And I think that might be the future of using YouTube, where
Oh my God, I couldn't agree more. And this specific example is something I've been bugged out about for so long. Look, I love podcasts, but I have very limited time. We're very busy at Orchest, and we're spending so much time working on the code and on the tool and with the users. So I would love to be able to tap into podcast content. How do I do that without listening to all of it? There's so much locked up. And so what I really like is that there are now tools that would let you do a hackathon project where you could literally take, you know, 50 of your favorite podcasts, download all episodes, do NLP to extract, the transcripts, and then to feed the transcripts into a vector search engine. Actually, it might be my next project with Weaviate and Orchest, but it's really, really cool to be able to tap into that kind of knowledge with the effectiveness of search. Because without search, you wouldn't be able to tap into that knowledge. So you really need a way to be able to quickly look at a large volume of data. And I think, Google really did a good job of doing search on the internet for web pages. but the world has turned into so much more data than web pages. In fact, I think fewer and fewer individuals are producing web pages, right? Like they're producing rich media content, and it's so important that we actually tap into the knowledge of that type of content too. And so, yeah, that just gets me super excited, as you can notice.
Yeah, we had Alex Kanan from Zencaster, which is the platform we're recording this Hollywood
Nice.
quality
Inception.
audio on. And he explained their efforts with podcast transcription search, and yeah, it's just such an inspiring thing. And coming back to what you're saying with the rich media, it reminds me of say Jeremy Howard with Fast AI. He made a lot of videos where he would be live streaming coding, and
Yeah.
so the live streaming coding, he's going to encounter errors doing that. That someone who's premeditating a YouTube tutorial on, say, Keras, PyTorch, like here's how you do a data loader,
Mm-hmm.
you're not going to see those errors. You're not going to quickly solve them as much. So the question answering flexibility that's enabled by these live stream coding sessions where you encounter the error and solve it in the real world, and then users is put it into Stack Overflow, they're lost. They need this new data source to solve this problem. Have you thought about like, what if you try to digitize all your knowledge and create a system like this?
Yeah, I think the potential, like, a lot of people gravitate towards low friction content creation, which is why these live streams are such a nice medium, because a lot of very smart people like Jeremy Howard, they need to be effective with their time. So if they can just do a live stream where they go into projects and showing things or how they're done, already that's so much value that's being given out. But how do you then increase the value of such content that's being created? I think it's by indexing it properly, so you can very quickly jump into content. I think a great example of this, where the necessity and the value of it is a simple phenomenon of YouTube chapters. Right, like you now go
Mm-hmm.
to videos that are long form and people commenting like, "Where are the chapters? Please give me the chapters." And there's no reason why, with the current state of technology, we couldn't generate those chapters or markers or be intelligent about like allowing people to jump to the relevant bit of content. I think the Jeff Bezos has an interesting quote. He always says like, bet on the things that are probably not going to change, right? Like, what is something that probably nobody's gonna look back on like, I'm not sure if that's going to be something in the future. And he mentioned the example of like, people probably don't want to wait longer for the goods to arrive, right? Like, optimizing shipping time is probably a bet you can make for like the next 10 years. I think attention and time kind of scarcity for people, especially like, productive professionals, is definitely going to be a thing in the future, because people are just getting less and less time to get to all the kinds of things they could be doing. There's just so much interesting stuff to work on, and so being able to work on technology that taps into that foundational trend where people are going to have to do more in less time and are trying to do more in less time, like I think that's really powerful. And to me, like these type of topics we just discussed are like all in that kind of bucket.
Yeah, I love that. And I think, yeah, like what won't change, like you can build this right on top of YouTube. There's no need to start an entirely new platform. It integrates perfectly. And the Orchest layer of adding the web scraping from Python, it made like Orchest is such a brilliant abstraction that it makes this whole application domain and this whole thing that sounds like a grandiose vision. It just is so easy to visualize how it would plug together with this abstraction. So coming back to Orchest, can you tell me about your experience with building a company, your visions for the future, and just, yeah, like what your experience has been building this company?
Yeah, happy to dive into that area. I think it's one of those things where I've learned so much over the past 2 years. I couldn't really imagine learning so much. And I remember thinking at the beginning, so we started a little under 2 years ago, we started working on Orchest. And I remember thinking, should I actually start a company now, or should I maybe get a job first and maybe get a bit more experience and then maybe read a bit more about how to start a company and like lurk some more on Hacker News and like get some more, advice under my belt. And I feel like at that point, I realized that I should probably just go and start building the company, because it feels like I'm kind of hitting a plateau on the kind of knowledge that I could absorb uh, from the sideline, so to speak. And so going into it, I realized that was very much true. It's very much true that there's only so much you can learn from observing other people doing a thing, and I think it's true for many areas. I think it's true for good examples for me that come to mind are mathematics and programming. Like, you can read about it all day, you can read all the programming books, but unless you've been in charge of building an actual system and dealing with the problems of updating software, state migration changes, like all of those examples and theoretical explanations are not going to stick as much because you don't really have the kind of experiences to kind of relate that knowledge to. And so I very much feel like that with the journey I've been on with starting this company is thinking about how to solve the problems that come up organically when you start a company, and like how do you convince people to buy into the vision that you're trying to realize without having realized that vision. Like, that requires in conversation to talk about um, the ideas you have in a way that makes it accessible for someone who doesn't know yet what you're trying to talk about. And so vocalizing thoughts around a product idea, like, that's something that's so hard to learn from a book, to be honest. So I really like that. I decided to take that leap, and I think I would advise if listeners are thinking about starting a company to just go and do it. I know it sounds super cheesy, and it's advice that's been repeated a thousandfold, but I really do think that at some point you just have to jump in, and you'll start to discover all kinds of things about doing it. And it turns out that there's also a lot of room for not doing everything perfectly. So yeah, that to me has been the reality, is like you kind of can only learn and grow so much from the sidelines, and doing it actually is what actually makes you kind of learn what it's actually all about. So I really enjoyed this new chapter of post graduation company building. It's been so much fun.
Yeah, and I think our artificial intelligence systems can learn a lot from that lesson too, where maybe like some kind of reinforcement learning, some kind of action would help them even take that leap as well.
Yeah,
And
yeah, yeah. I think if you're never going to take an action, you're never going to get that signal. So where's the reward, right? You don't know.
what has been the most challenging, say, new skill for you to learn as becoming a CEO?
I would hands down say thinking about how to make other people successful, because computer science and software engineering and even theoretical research at university is pretty individualistic. You just have to really own the material. You have to go to the lecture, understand all the complex topics that are being communicated. You try to absorb all of it, and you try to synthesize that knowledge into being able to apply that knowledge to new problems, and like in a way just generalize to new cases. But that's like a very individual process. It's like you and the theory, right? You and the knowledge. And what I've realized when you start a company, it's you're trying to set up a group of people for success, and the way to do that is to figure out what's preventing them from operating at maximum velocity. So what's holding them back? And it's also about prioritizing, but also figuring out prioritization in a way where you can direct people to work on the right things in a way that uh, actually works with the way they work. So you can't just ask people to shift targets every other week, right? You need to also take into account the cost of switching, the cost of realigning what you're working on. So and you also need to take into account what are their goals, right? Like, if they want to learn more about a particular area of programming, or like how can you kind of make all these like combinations that end up making people happy with the kind of work they're doing, and like not waste their really good potential. Because we've been able to attract, we've been super lucky to attract like really, really smart people who really know what they're doing. And like, I feel pretty big pressure um, to not mess up their capacity. Like, if I let them work on the wrong thing for months, like, that's on me. I'm wasting their time. It's not like their fault that they're working on something. And it's like a two-way street, right? Like, you don't dictate like what everybody's doing. It's like you talk about it with everyone involved. Like, what do you think we should be doing? What is your idea of like what's the highest impact thing we could be doing right now? And so I think those are all new experiences that I very much was and am challenged by, and I try to do as good of a job that you can do without having a PhD in that kind of stuff, right?
Yeah, it sounds so interesting, and definitely like something that you need to learn on the job too, with the just the nuances of people's personalities and all sorts of things like that. And so on this topic further of the high impact thing, and not to give away the secret, but do you have like a like a thing in the say 6 months to X years or however the time span is that would be added to Orchest that you think would be a game changing thing?
We're working on something that I think is really big, and it's always been part of the vision, but we're now actually close to realizing it. And we've always felt that there needs to be a proper abstraction so that distributed systems level performance, where things are fully distributed, running independently, and performing at the maximum capacity of machines on which it's run, not by like the manual work of a coder, that data scientists can actually take advantage of the hardware that we have at our disposal. Like these cloud platforms, they have wonderful scaling capabilities, but more often than not, it's still frustrating and complicated to actually tap into it. How often do you not find yourself kind of just serially saturating a single node that you're on? And so we've designed Orchest from the ground up because of the containerization primitives to be able to schedule over a large cluster, maybe hundreds of nodes in a Kubernetes cluster, to be able to run all kinds of code in parallel. And even within single pipelines, being able to split up independent tasks and run them simultaneously, even on heterogeneous nodes. So maybe one task is very memory bound and one is very CPU bound, and being able to allocate there. And what we're what we're soon releasing is, as part of the open source project, it will be this fully distributed version where the control plane of Orchest itself is fully independent from all of the scheduled tasks that are running as part of the pipelines. And so this, I think, is really exciting. We're actually going to do a live release at the upcoming Data Council event in Austin. So that's going to be hugely exciting for us and the whole team. And, that vision of making it that simple to deploy these production ready batch data pipelines on a large cluster of hundreds of nodes with the simplicity that we have in the tool today, I think, that is going to be a very exciting milestone for us.
Yeah, I completely agree. I'm thrilled to know about Orchest now, and yeah, that abstraction sounds amazing. The swiping in and out of different cloud services within this pipeline abstraction already, and the containers, incredible. So what is so kind of like one more meta question about your general training, so to say, is how do you kind of do your information diet? What kind of do you read blog posts? Do you read scientific papers, experimentation?
It's a great question, and I saw this around. I saw this hint being given by other people. I think just recently I heard it mentioned by the guy who founded AppSumo, who's an interesting character to follow. But it's about so there are a number of information sources, but how I actually digest it is by writing down a lot. I write down a lot. And I think Paul Graham has this really cool essay as well about how if you haven't written about a subject, you don't really understand it or you don't really know enough about it to be considered an expert on it. Because when you write, you kind of have to be honest about what you actually mean, right? You can keep stuff pretty vague inside your head. You can like keep it kind of like partially defined where you think you know, but you don't really know. And everyone, everyone who's written a master's or PhD thesis will know what it's like when you try to formalize your thoughts and then discovering gaping holes in your understanding. So, in terms of information sources, I try to really I'm a very active lurker on Hacker News and sometimes Responder, where a lot of interesting software thoughts are being shared. I think for academic knowledge on deep learning, and I really like also kind of more quote unquote simple mathematical analyses of maybe like a support vector machine and its generalization capability. So like for papers, I tend to rely on like Twitter feeding me, the relevant and interesting articles that are up in archive. And then I tend to browse Reddit because I really like how kind of brass tacks it is. Like people talk about very specific types of challenges that they're facing in their work, and their work as a data scientist, and like tool comparisons and that kind of information. And then there are some quite good books that are being written. So there's lately been a book I picked up that's about. We can maybe link it in the show notes because I don't know the full name and author, but it's about basically the modern data pipeline setup, and how to think about the differences in ETL and ELT, and how all these concepts kind of map to different types of tools and technologies now. So using like a very diverse collection from papers to social channels like Hacker News and Reddit, and books, I will try to distill the knowledge into written form that are like private notes. I don't keep them private because I don't want to share. It's more that if I know that they're private, I can write more freely, and that it actually works more as a device for kind of processing the information. And I also like to make lists. So I have this website called www.alldatatools.com. It's an open source list of all the data tools that I could find that are targeted at technical professionals. So I excluded like no code tools because I feel like it's a category that I'm not specifically trying to map and catalog. But it's really kind of a way for me to also have a good kind of taxonomy and a list of what's going on in this space. And I like to use that as a tree to also kind of connect the knowledge that I'm gaining to. So some areas of NLP, some areas of more engineering topics. And so, that's just a little bit of how I try to structure my thought. But I don't know. What do you do?
Oh, well, yeah. I really like the idea of the lists. I've tried to take lists, but I find it can be kind of intractable. Like it blows up quickly when I try to just do a top down list, and I struggle to uh, keep the high level categories that map the list and keep that ontology sane, sort of with deep learning research. But yeah, I completely agree. I love writing. I think writing, it forces you to, as you say, be clear about what you really know. And yeah, I for me, writing is definitely a huge source. And then yeah, Twitter, the social feeds, definitely disagree with all that. And then I do think running experiments is also just a huge way to build your knowledge further. As you mentioned, with the experience of building a company, you need to actually do it, and just in general, making sure you're doing it instead of just talking about it too. But yeah, really cool stuff.
Nice.
So
Nice.
thank you. Yeah. So thank you so much, Rick. I thought this was such an informative podcast. I'm so excited about Orchest, and I loved hearing about the integration with Weaviate as well. I think this is such an exciting thing for the future of data science and deep learning technology becoming realized into things like, as we talked about, the future of blogging, where you could have a direct question with a blog or a YouTube channel. And I think all these things are just really coming together in such an exciting way. So thank you so much for coming on the Weaviate podcast.
Thanks for having me.